Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video for research potential series, I'm going to talk about research potential on explosive compaction using powder. Okay, so basically, what is a uh, explosive compaction? Okay, explosive compaction is a method to compact within explosive. Obviously, is method to compact within using explosion. Okay, because explosive, they have the power, tremendous heat, tremendous load, tremendous force to compact, and then theoretically it can compact anything. This method have been used uh, in many research. They use to compact sandwich material. Okay, sandwich material is like, okay, sandwich is like okay, sandwich material. Okay, and then they put the explosion outside it, and then the impact, it will be bonding. Okay, this is called explosive compression on sandwich material. But for powder itself, okay, for powder itself, uh, not many have done it. Okay, I made this video to help you for potential student, so students who have access for this kind of research, for this kind of research facility, because using explosion, not many research institution have this capability. In Malaysia, only National Defence University in Malaysia they have. In your country, maybe you have, maybe you don't have. But for those uh, research institution that have this kind of facility, very advantageous, because lot of things you can do. Lot of things you can do using explosion. Okay, you must get permission from relevant authorities like the military, like the police, and all other relevant authorities. This is the challenges to do this kind of research, and then the cost of doing research is also very high compared to normal research. Okay, but this is a challenge, and just enjoy doing the research. Okay, not many are doing research on powder, kan? Not many are doing research on powder itself. Okay, because obviously it is difficult to have to get this kind of research facility. Okay, and then uh, powder itself, okay, not many are doing it. This is a research gap, research potential for you, because for if I go for research for insider rank for 5 years back, only 40 research doing on powder. Okay, as I analyze, if you go back before September 11 attack on US, many are doing research on explosion. Now after September 11 attack 2001, uh, it seems that research on explosive going down, and not many doing it, because because obviously uh, restricted restricted availability on explosion and relevant authorities. Of course, but in the end, if you have the opportunity to do it, very good to you. Okay, so the powder itself, okay, the powder itself is like this. Sometimes it is difficult to bond the powder, because when you want to bond the powder, you want to bonding, it need tremendous heat, and then the powder particle going inside. Okay, the small particle going inside the bigger particle. This is the big particle. You want to insert the small particle inside the big particle. This need this need force. Okay, force given by normal pressing machine. Sometimes it's not enough. Okay, if you can able to do it, you can build up the material that is stronger, material. Okay, uh, but if you are thinking about costing, of course, uh, if you want to manufacture it as mass production, uh, uh, better doing for heavy press forging. But sometimes most of the time heavy press forging cannot achieve that force. But in the end, if you in future generation you have the technology, you can do explosion in mass production. It's very good to you. It's very good because many application you can do using powder itself. Okay, explosive compaction on powder. So it is there is a video I made on explosive pressing. Okay, the difference is obviously one is compact and one is pressing. If you do the pressing, there is a one video I made on the explosive pressing. Okay, you put the explosion. This is the plunger. This is the explosion, what any kind of you want, and then this is the target. This is the specimen. Okay, and then with the press, it is press. Okay, this is like pressing. If in compaction, you have gap, gap. You have a gap. Okay, there is a gap between target and this. However, what you can do anything to make a gap. Okay, make let's say you put a polystyrene, you put a plastic, as long as there is a gap, it is compact. Okay, this is the difference. Obviously, this is a difference between uh, compaction and pressing. Okay, uh, this is gap is called stand-off distance. This gap is called in this kind of research. This gap is called stand-off distance. Okay, let's see potential detectors people have done this research. What they have done, they found the shock wave pressure is dominant to power densification of particles side of powder. Okay, the degree of compacting picture of cement and powder with metal under compaction is determined possibility of arrival of shock wave. The use of particles for diamond having unique properties, and then realize an approach with use mathematical and physical modeling. Okay, of course, many research are using modeling to simulate it. They are using software like Abacus, Autodyne, and many more. For physical experiment, if you have the ability to do it, it's better because you can compare the result and gain a lot of experience in doing it. And then this is among the problem statement, joint theoretical experiment identification to allow how to realize and approach using use of mathematical and physical modeling. And then basic compaction technology is problem because aluminum oxide is extremely hard and refractory material sometimes, meaning that you have material itself is very hard. Okay. Uh, then the development optimization of scheme for expressive compaction of mixture of solid powder material with metal bond. Okay, because of the heating element, because of the heat generated is so high that it can bond itself. It's also related to sintering, also related to explosive sintering, explosive welding, which is I will cover in the other videos. Okay, so objective process of explosive compaction produce nano diamond powder together. Okay, sintering fabrication high density tungsten copper alloy on copper surface, duration durable low porosity contact sample, uh, effect of radiation velocity, tungsten content. Okay, this for those who want to use tungsten as their project, their specimen. Okay, this is the expected result. You can read it. The scanning electron microscope exhibit layers of graded materials highly integrated because hardness test related gradient trend. Okay, meaning that from my experience, meaning if you compact this material, it becomes stronger. Hardness, the hardness, because hardness, you show increase the result. Okay. Uh, Correlation of pressure threshold for various powders of metals and mixed with generation procedure and you can read all. And this is a chapter methodology, meaning that this I myself with my student we have listed we have done the analysis on those journals and we find out this is the tools that you may want to use when you are doing this kind of research. Okay. Test, you have to do tribological test, porosity test, comparative test, scanning electron microscope because tribal test method, high energy method, uniform directional method, uh, shockwave impact, explosive electrical explosion, simulation, okay. And then this measurement, you have to measure the tension resistance, shear strength, macro hardness, compressive strength, thermal conductivity. And then the equipment that you have to use, optical microscope, scanning electron microscope, prediction machine, high speed camera, of course, high speed camera, application pressure bar, expanded reflection, and then mathematical modeling, and then equation that you have to use. This is a model equation we can detect from the all the abstract parameters you use, dynamic compaction parameters on explosion, loading parameters, processing parameters, and everything. This is the model, two-dimensional model, straight mechanical macroscopic modeling. This is the crack that appear on crack on the specimen surface. Properties, quasi-static compression properties, properties of metallic powder, thermal properties. This is an experiment, okay, that you may use sparring plate, loading experiment, explosive compression element oxide powder, okay, in impact initial experiment. This is analysis, structural analysis of mechanical properties, dimension analysis, scanning calorimeter analysis. Then this morphology, you might study morphology of diamond matrix boundary, SAM, fracture morphology. Okay, deformation, shock wave deformation. Of course, the material, the powder that you will undergo deformation. Okay, then plastic deformation, elastic deformation, and then compressive strength, shear strength, bonding strength, dispersion strength. Okay, mechanical strength. Prediction. This is if you are interested in doing simulation of it, you may predict. Okay, prediction of metallic behavior, metallic powder behavior, multi-material hydrocode. This is genetic programming approach, soft chemical approach, dislocated approach, and this is fracture mode, bonding mode, synthesis mode, optical mode, compaction mode. This is the if you are related to rate, you are dealing with high energy rate, high strength rate, high large quenching rate, solid state rate. Okay, this is a system, mechatronic microposition system, cylindrical compression system, diffusion bond. This is a technique you may use: hot explosive consideration, cold spray technique. Okay, this is among the software that is mentioned in the all the abstract. Autodyne, the famous one, Autodyne, dedicated software to do explosion. Autodyne by insist. Okay, and then hardness, brittleness, explosion. This is among that you may study. Corrosion resistant, temperature resistant, electrical resistant, time of explosion, compression, bonding time dependent, problem, shock, with impact. And then this is a material that have been studied. There are many more. Just list a few. What? Don't be panic. The list you can see, you can pause, you can go back to the video to the list. This is among the list. There are many more. Don't be panic. When you are doing this research, just consult with your supervisor. Uh, List out the equipment that you have in your facility. If this kind of equipment you don't have that in your research institution, don't do it. Okay? If the equipment is so expensive to buy, don't buy. Use whatever available. Okay. For doing master, doing PhD, we this video has listed all the tools that you may use. You may use most of them. You may if the equipment is not available at your research institution, don't use it. Okay. Don't use it. Okay, this is the list as a guidance for you only. Uh, if you are really interested to do this kind of research, you can download, you can get the full document in the link in the description of the video. I wish you the best to do this research. Research is not that hard. Okay, if as long as you know the technique to do it, it's very easy. I cannot say that easy, but you can be done in a structured method. Just enjoy your research. Just enjoy. You can grade it all the time, just in enjoyable manner. Okay, so I wish you the best. Thank you very much.